Another fun session on the new topic introduced by SSC in this year in the various examinations, mod-based division of arithmetic reasoning. So mod-based division, a lot of you are partially familiar with this, a lot of you are not. So by the end of this session, our main objective is to understand this concept from ground zero, and we'll only go up to a level where you can expect questions or where we have seen questions in the examinations, right? So this is something new. It was not being taught regularly, but I'll tell you by the end of this session, you will feel that you have already solved this, okay? The main purpose of this session is not to learn the basic. The basic you already know. One line I'll tell you and you'll understand. But by the end of the session, you will understand where we have utilized this in logical reasoning, okay? And we have done it in my classes. In all the sessions, you will always see that we are using it partially. So let's start today's session, that is modulo division. But before we start, a quick update to you that if you are still, yes, we are very close, but I would like to tell you that the new interface mocks and the new style mocks are coming up. And if you see, these days the level of the mocks is constantly increasing. So go ahead and solve these mocks quickly as much as possible. Clarify your doubts so that no issues come to you whatsoever as far as your preparation is concerned. And if you're a super elite subscriber, you can watch these courses free of cost. The crash course and complete revision course which is there, super practice is also available. So go ahead and check it out and make full utilization of it, right? Now, when I speak about the modulo division, our objective today, as I told you, it's to understand the complete concept and application of modulus operator, that is modulo division, not the regular modulus operator. The regular modulus operator is this. I'm not talking about this. This is different. This also we use in reasoning at some places, something like this. Like if I say 27 minus 5 under the mod, that is something else. I'm not talking about that, but I'm talking about this. Okay, so not percentage, okay, the same sign is used there. So we'll understand about that from the new pattern of SSC and we'll practice a few questions based on it. Okay, and no need to make notes, no need to do anything, everything I have made it here for you. So I'll share this PDF with you, everything will be available here as much as you need, and a brief practice of some questions, and modulo arithmetic will not be a problem for you. Right, now let's start. So first let's understand what is the modulo division or the modulus operator. Basically, if you know this law, dividend equal to divisor into quotient plus remainder. I think we all know this. Cool. Dividend is equal to divisor into quotient plus remainder. We have all learned this already. We have always heard about this. This is the Euclid's division lemma. This is the Euclid's division lemma. You have all learnt about this since you were little children and you already know this. So if I have this as a dividend, if I'm dividing it with a divisor, I'll get a quotient here, something will be subtracted here, and finally I'll get the remainder as answer. Remainder may be 0, 1 or any other number. Okay. So whenever I use this sign between two numbers, for example, this is known as division. And how is this also represented? So it is either this sign or simple slash. Okay. Now slash can be normal slash. I can write it like this: 10 by 5 is equal to 2. Okay. Or it can be fraction also. Okay. Or I can say fraction. In all these three cases, I call them division. And what is the answer? What is the return value? What is returned to me as an answer? It is always a quotient. So for example, if I write 10 divided by 5, or I'll write it as 10 by 5, or I'll write it as 10 upon 5. What will always my answer be? 2. That means when I divide 10 by 5, I get the quotient as 2. It's a very simple process. You already know this. Okay. But what if I don't want this 2? I want to divide two numbers, but this time I'm more interested in what is the value of this. What is the remainder? So in that case, we change the operator, and rather than giving you a straight division sign like this, they tilt it. They mix this and this, and this becomes this sign, which looks like the percent sign, but is a modulo division sign. Either we use this or we use the word mod. Okay, this stands for modulo division. Okay, so this is known as modulo division. This is not regular division. And in this modulo division, what is the return value? The return value is the remainder. The return value is the remainder. So if I am doing this here, let's say I say 10% 5. What is 10 modulo 5? Okay, and I'll also give you, let's say 10 modulo 7. Now 10 modulo 5, that is if I divide 10 by 5, what is the remainder? The remainder is 0 because it is divisible. And 10 modulo 7, so you will say 7 into 1 is 7. So how will you write this? You will write this as 7 into 1 plus 3. So this is dividend equal to divisor into quotient plus remainder, correct? So what is the remainder? 3. So my answer is going to be 3. Okay, so how do you make it quicker? Whenever there is a modulo sign in between, you quickly just take the multiplication of 7 and go to the nearest number. 7 ones are 7, just subtract 7 from it. 3 is left, 3 is your remainder. That's all. That is all about modulo division, and you have already heard about this with me in a lot of classes. I'll tell you the specific topics by the end of this session. Okay. Now let's look at the actual interesting aspect of it. This much you know, and technically you will be able to solve questions based on this knowledge, but who knows that they are going to raise a bar a bit, because so far whatever questions we have seen, they were very easy questions. But what if they change it slightly? So you need to know some properties involved here, basic mathematical properties which are involved, which will help you understand the concept of modulo division better. Okay, so this is what we have already understood. Cool. Now these are the properties. Commutativity. Commutative property of multiplication and addition. It implies that if two numbers are added in a direction and if I change the direction, so 2 plus 5 will be equal to 5 plus 2. 7 into 9 will be equal to 9 into 7. Similarly, if I apply the mod commutatively, I am multiplying two numbers and I am applying the mod. So A into B mod M will be equal to B into A mod M. That will not going to change. Okay. Next, addition property. If I am adding two numbers, A plus B mod M. So rather than adding them and finding the mod, I can individually find their mods and then add those mods and find the final mod. So either this is given, I convert it to this, or this is given, I convert it to this. Remember, you will not always use this in one direction. Why? Because sometimes you will see finding it like this is actually time consuming. Sometimes you will see finding it like this is actually time consuming. So you'll have to convert vice versa as per requirement. You need to know both of them. Okay. This is an example. So 18 plus 15 mod 7. I'll just show it to you here. 18 plus 15 mod 7. Okay. 18 plus 15 mod 7. We have two options here. Either we solve it like this, 18 plus 15. So this is 33 mod 7. This is very easy actually. And nearest multiple of 7 here, 28. Okay, so 28 and 33 is how much? 5. Cool. So I'll just write it for you here. This is 7 into 4 plus 5. So 5 becomes my remainder. What if I wanted to do in a different method? The method which I have told you here. So 18 plus 15 mod 7. If these were large numbers and it was difficult for me to actually divide them. So I could have written this as 18 mod 7 plus 15 mod 7. And if the number is greater than 7, then I'll have to take another mod 7. This is important only if this is greater than 7. If the sum is less than 7, then it's useless. Okay. So 18 mod 7, you'll quickly say it is 4. 7 into 2 is 14. And again it is 1. So this mod 7 is useless actually because we have 5 here. So 5 is my answer. Because 5 mod 7, any number which is less than 7, the mod is always going to be the same number. Okay. So the answer is 5. See, either which ways you will see the answer is always going to be the same. You are being taught this, but nobody is being taught this. So this is a property. It holds true. You need to know this. Okay. I'll show you both type of questions where you will see actually application of this will be easier. Sometimes application of this will be easier. And the faster you will get, the better it is. Okay. Next, multiplication property. Again, like addition property, we have the multiplication property also. A into B mod M again is A mod M into B mod M mod M. Same thing. Okay. I'll show you another example for that also. So this is 18 into 15 mod 7. 18 into 15 mod 7. Now this time you will feel that, okay, rather than taking the product and finding the mod, I should go by the property. So let's try it with the property first. You will see the difference. Or let's try it like this first. 18, 180 plus 90. 180 plus 90 is 270. So this is 270 mod 7. See, our calculation is fast, hence sometimes this will also seem to be faster. But technically multiplication would have been problematic. So 270 mod 7 is how much? Nearest multiple of 7. So if you can't find it, if you can't find the nearest multiple, what you can do is you can simply divide 270 by 7. In the fraction form, don't actually sit and divide it. And then you will see, so 3s are 21, 60, 5s are, 8s are 56. So we are left with 4. So 4 is our answer. 270 mod 7 is 4. 264 was divisible by 7. Now what about this? So this will be 18 into 15 mod 7 is equal to 18 mod 7 into 15 mod 7 whole mod 7. Depends, this whole mod 7 will be useful if the number is greater than 7. So yes, 18 mod 7 again is 4, 15 mod 7 is 1, mod 7, so the answer is 4. Okay. Now by chance the product came out to be fast, otherwise this would have been slightly problematic. Okay, the power property, one of the most important properties. You don't know, but you are actually using this indirectly in quant also, whenever you're finding remainders. Okay. So the power property says that if I have a mod, okay, if I have a mod, something like this, a raised to the power k mod m. So rather than solving the whole thing here and then finding its remainder, I can find the remainder of the base and then the power and then the remainder of the rest of the number. Okay. For example, 10 raised to the power 100 mod 3. 10 raised to the power 100 mod 3. Now technically a lot of people will think that I have to solve this 100 zeros after 10. How you can go about this is just solve this as 10 mod 3 raised to the power 100 mod 3. This mod 3 again will be useful if this is greater than 3. Now 10 mod 3 is how much? 1. 1 raised to the power 100 mod 3. Now you only tell me what is 1 raised to the power 100? That is 1 only, no? And 1 mod 3, if it is less than 1, less than 3, it is always going to be the same number. If it is less than the divisor, if your dividend is less than the divisor, then the dividend itself is the remainder. Always remember that. Easy? So what is the remainder when 10 raised to the power 100 mod 3? So now it is simpler. Okay. So far nobody, you might not have seen such a question in your exam, but even if it comes up, it's not a very big deal. It's a very easy question actually. So these are the properties of mod based or modulo division. But we can make it faster by applying these properties. So we need to learn those small tricks also. Okay. What are those small tricks? So one thing is you break down large numbers. Like we just saw that I showed you with small examples, but what if the calculation is very large? Now so far a lot of you, what they are doing is they are solving the left hand part of the mod completely first and then taking the remainder with the right hand part. That is actually a useful technique provided you have very small calculations involved. But what if you have large calculations involved? In that case, you cannot sit and calculate the whole thing. It's going to be very time consuming. So then you individually apply mod and then find the answer. And then even if the answer is greater than the divisor, again find the mod. That's how it works. So that will seem to be easier. Apart from division, you can use it everywhere else. Multiplication, addition, subtraction also nobody will, subtraction is also slightly different. But multiplication and addition, you can use that. Okay. Now, so this is another example. 234 into 567 mod 5. Let's try this now. 234 into 567 mod 5. Now you tell me, if you're sitting in an exam, are you going to multiply this? Isn't it time wasting? So what are you going to do? So you're going to do this as 234 mod 5 into 567 mod 5. And if at all it is required that this is greater than 5, I will still write a mod 5 outside it. Keep taking remainders with 5. So 234 mod 5, what do you think is the closest multiple? Whatever it is 0 only, 230. So 4 is the mod. This is 565, so 2 is the mod. 4 into 2, this time we have 8. So this is 8 mod 5, which is how much? 3. Now this will seem to be easier. a larger number rather than multiplying and finding it, you have found it very easily that 3 is going to be the remainder. Cool? That is what is given here. Okay. So first thing is break down the larger numbers into individual mods. Second is you can use negative remainders. Now this is a very common trick actually. Supposedly I need to find the mod for 999. 999 mod 10, 9. Let's keep it 999 mod 9. Okay, let's keep it 10 only. Now technically what I can do is I can divide this by 990 and I would have gotten 9 as my answer. That's not a problem actually. You know? If I would have divided this by 10, I would have gotten 990 as my quotient, and if I would have subtracted that, I would still get 9 as a remainder. Not an issue. But how can I make it faster? So what is the next closest number but after 999? It is 1000. So 10 into 100 is 1000. Okay. So 1000 minus 999, or rather I should write it as 999 minus 1000 is equal to minus 1. And now add this again here. So whatever is left will be your remainder. Okay. So you can also use negative remainder sometime. Minus 1 is actually not the remainder. Your remainder is supposed to be positive only. But you can convert it to a negative and then finally to a positive to make it faster than going directly. Okay. You will see all these applications somewhere or the other. And this is one of the most important tricks you are going to use. One of the most important ones you're going to use. Okay. One of the most important tricks for your calculation of mod based modulo division. Cyclicity of remainders. Okay. Now, for example, this is the question they're asking you. 7 power 100 mod 10. Find the last digit of 7 power 100 mod 10. Okay. What last digit or remainder of, I believe. Okay. So how do we do this? What is the remainder? This is what they are trying to ask you. This is not last digit. They are trying to ask you what is the remainder if 7 power 100 is divided by 10. That was the question. That is 7 power 100 mod 10. Now, if I do this, firstly, what you will think is this is 7 power 100 mod 10. Then you will say, oh, we know this. You only taught us right now. We will say that this is 7 mod 10 power 100 mod 10. What is the problem? But this is the problem. 7 mod 10 is 7 only. So this will convert again in the same problem. This is useless for you. So what do? You check the cyclicity of remainders. Okay. You check the cyclicity of remainders. You will check that 7 power 1 mod 10 is 7. 7 power 2 mod 10 is 9. 7 power 3 mod 10 is 3. 7 power 4 mod 10 is 1. 7 power 5 mod 10 is again 7. So 7, 9, 3, 1. The cycle is repeating in the length of 4. Okay. Cycle of 4, 7, 9, 3, 1, 7, 9, 3, 1. These are the remainder sets repeating after every fourth remainder. Okay. Now you have a power of 100. So what is the remainder? So divide this by the cyclicity. Divide this by the cyclicity. And if the remainder is 0, that means it is going to be the fourth part. No? 1, 2, 3, 4. 1, 2, 3, 4. So if the remainder comes out to be 0 when you divide by 4, it is going to be the fourth digit. If the remainder comes out to be 1, it was supposed to be the third digit. If it comes out to be 2, it was supposed to be second digit. If it comes out to be 1, it was the first digit. But this depends on the cyclicity. So what did we do? We said that, okay, let me find out 7 power 1 mod 10. That is easy. I can do this much. So how will I do this? I will say 7 mod 10 power 1. Correct? This is 7 mod 10 power 1. Not need to solve this actually because 7 mod 10 is 7 only. So this is my first remainder. The second is 7 square mod 10. Now you can convert this 49 mod 10 also, not a problem. See again 49 mod 10. Okay, are you getting it? So 10 into 5 is 50 minus 1, you can do that. But how do you attend this one? So this is 7 mod 10 square mod 10. 7 mod 10 is 7 square, 49 mod 10. Arey yaar, what am I doing? One and the same thing only, no? What's the point? So this is 49 mod 10. So 49, 9 is my remainder here, isn't it? 7 cube mod 10. So 343 mod 10, 340. So 3 is my 7 power 4 mod 10. 7 square, 7 square, 9 into 9, 81, and 81 with 7, 1284, 1177, 77, 81 is 5, 7935, I'm getting different numbers, 7931, okay. Now if I take 7 power 5 mod 10, this is again going to be 7. So this is cyclicity. This is cyclicity. Okay, cyclicity is equal to 4. That means after every 4 remainders, the remainders will start repeating itself. After every 4 remainders, the remainders will start repeating itself. So now we are at the 5th remainder. Now the question is, what will be the remainder in this case? So we have power 100. We will divide this by the cyclicity. Okay, what is the remainder? Remainder is 0. That means whatever will be the remainder will corresponding to this. So this is 1, 2, 3, 4. These are 4 cyclicity. So after every 4 digits it is being repeated. First 4 set, then second 4 set, then third 4 set, fourth 4 set, 4 set, 4 set, 4 set. Our remainder is 0 by dividing by 4. So we are talking about this 4th digit which is being coming 25 times to get our answer. So this will be our answer. So 1 will be the final remainder if I divide 7 by 100 mod 10. Okay. That's how you need to understand this. Okay. Now let's proceed to some practice questions. So try this. So now this is the text form of your question. What is the remainder when 145 into 287 is divided by 12? Or this is the mod form of your questions. They will ask you like this: 145 into 287 mod 12. What is the answer? So what trick will you use? What trick will you use here? This is 145 mod 12. Into 287 mod 12. You don't have to write this, you have to do this verbally actually. Mod 12 in case the number is greater than 12. So 144 is the closest one, so this is 1, and 144 into 2 is 288. 288 and this is 7, so this is minus 1 and plus 12. So this is how much? 11. 1 into 11 is 11 mod 12, so 11 is my final answer. How fast was that, wasn't it? Now you see how minus helps you out. I told you, I'll show it to you in the examples. This is how minus will help you out. Technically, you could have gotten 288 and 12 minus. That is 276 also. Correct? And 276 and 287. So then you could have solved it like that also. You could have still gotten 11 only. But this is a faster method because you know 288 is divisible. But this is just plus 1. So you will subtract them. You will get minus 1 and then you will add this divisor here to get your answer. The moment you get a negative value, you add the divisor again to make it positive. Okay. Next. 7 power 2023 mod 5. 7 power 2023 mod 5. Now let's check the cyclicity. Okay. 7 power 2023 mod 5 is 7 mod 5 power 2023, and if obviously this is not going to be less than 7. Now 7 mod 5 is 2. So this is nothing but 2023. 2 power 2023 mod 5. So what you will do is you will find the cyclicity of 2 mod 5. Okay. Cyclicity of 2 mod 5. 2 power 1 mod 5. 2. 2 power 2 mod 5. 4. 2 power 3 mod 5. 3. 2 power 4 mod 5. 1. 2 power 5 mod 5. 1. Wait. No, 2, sorry. 32, no? So now I know that this is going to repeat. So again, cyclicity is how much? 4. Cyclicity is how much? 4. Cool. Now divide 2023 by 4, but take the modulo division basically. So what is the remainder which is being left? What is the remainder which is being left? So 2020 I think will be divisible by 4. Don't you think? So 3 is the remainder. Okay. 3 is the remainder. Now what is the corresponding value with 3 remainder? Corresponding value with 3 remainder. Okay. So what will we do here is, if 3 is the remainder, we will see corresponding value either as 3 here you will see. So what it is, this is 2023, 2 power 2023 by cyclicity is nothing but 2 cube because of this 3. Okay. And now if you take the remainder of 2 cube with mod 5, 2 cube with mod 5, what do you get? You will get 3. But even if you don't do it like this, you will still get the answer 3 only. From here only you could have gotten this. Okay. Next. This one is an interesting question actually. No Gopi, that's not the answer. Now a number n leaves a remainder of 3 when divided by 8. What is the remainder when 2n plus 5 is divided by 8? So what is the meaning of this? This is the statement format, this is the mod format. N mod 8 is equal to 3, then this mod 8 is how much? If n mod 8 equal to 3, what is the value of n? What is the probable value of n? The first minimum value of 8, n. That means n is being divided by 8 and 3 is the remainder. If n is being divided by 8 and 3 is the remainder, you will take the smallest multiple of 8, that is 8, and you will add 3 to it. So basically what is n? In minimum value of n is what? 11. Right? Minimum value of n is what? 11. That means 11 divided by 8, remainder is going to be 3 only, no? Now put this 11 here. So this is how much? 2 into 11 plus 5 is 22 plus 5 is 27, and 27 mod 8 is how much? 3. So option B is the correct answer. Again, this is statement form, this is mod form. They can ask you either of them. Mostly they are asking like this now because students don't know what is mod, but they could have asked you like this also. What is the remainder when the product of the first 10 prime numbers is divided by 10? Remainder when products of the first 10 prime numbers is divided by 10. A very interesting concept here. Very simple, very direct, very basic. Now a lot of people will feel that I need to find the product of these numbers to get the actual remainder with 10. But technically, if you see what is 10? 10 is the product of two prime numbers 2 and 5. They are both here. They'll get cancelled. If they'll get cancelled, you'll get a value which is actually the quotient, and what will be the remainder? 0. This is divisible by 10, no? Because of 2 and 5, it is divisible by 10. Therefore no remainder. Therefore remainder equal to 0. So if I modulo divide this by 10, my remainder is going to be 0. Okay, next. A mod 9 is 5 and B mod 9 is 4. What are the minimum values of A and B? A mod 9 is 5 and B mod 9 is 4. Then what is the remainder when A into B square is divided by 9? If A mod 9 is 5, just open this only, no? Open this only. What is this? So this is A mod 9 into B square mod 9. Correct? Now this is A mod 9 into B mod 9 whole square mod 9 if needed. You should have put it here also, mod 9. Now what is A mod 9? A mod 9 is 5 into, what is B mod 9? B mod 9 is 4 square mod 9. Now this will become easy. So 16 into 5 is 80. So we need 80 mod 9. 80 mod 9 is how much? 72. So 8. Cool. So it's not everywhere that you'll have to do it directly only. You will need the formulae, you will need the properties, so that you can break it down and get your answers more easily and more quickly. Otherwise, what you would have to do is, this can be A is 14 and B is maybe 13. Can you check it? 14 into 13 square mod 9. What are you getting? 14 mod 9 again. Same thing only, no? 14 into 13 square. 13 square 169 into 14 mod 9. That's going to be too long a calculation for you. Unnecessary, I mean. Which we don't need. You'll get the same answer only though. Next. 15 square plus 10 square mod 4. Now this is one of those questions where even if you solve this first, shouldn't be a big problem. You can solve it with both the methods. 15 square is 225 plus 100 mod 4. Either you solve it like this. First method is 325 mod 4. That's the best approach actually. Technically 324 will be the one divisible by 4. So we'll have 1 as my answer. Okay. What else can we do? We can do this also. 225 mod 4 plus 100 mod 4 mod 4. So which is equal to 225. No, not 222. So again 224. So 1 plus 0 mod 4. Now 1 plus 0, 1 mod 4 is 1 only. What is another method? Another method is, we can do this. 15 square mod 4 plus 10 square mod 4 mod 4. 15 square mod 4 is 15 mod 4 whole square, again mod 4, plus 10 mod 4 whole square mod 4 whole mod 4. I am not writing mod 4 again and again. So this is 15 mod 4. So 3 square 9 plus 10 mod 4 6 36 mod 4. So this is 45 mod 4, which is again 1. Either which ways you proceed. This is one method. This is the other method. And this is the final method. Now you will see that the properties hold true. Okay, you can use either this or this, or you can use this, whatever you are feasible and comfortable with. But you need to know them. That is what this is all about. See, now sometimes we said that solving this indirectly and getting your answers is going to be time consuming. Sometimes this is the fastest method. So it depends, because you know some numbers, you don't know some numbers. That's the whole game. Okay, next. Sorry, what? Same question. Next, this is the next question. So 4 is equal to 158 mod k. Then what is the value of k? 4 is equal to 158 mod k. What is the value of k? So if I am dividing 158 with something, I am getting the remainder 4. Right? If I am dividing 158 by k, I am getting the remainder 4. So if I add 4 to 158, should be divisible by k, right? 162 should be divisible by k. Now if you observe, 162 is not divisible by 4, but this is divisible by 2. This is not divisible by 11 also, not divisible by 7 also. So 2 only is my correct answer, option B, right? Correct? (158 mod k), if I divide something by k, I will get 4 as a remainder. So 4 is a remainder. If I sorry, I have to subtract this by 4, not add. My bad. I have to subtract 158 and 4. So I'll get 154. Now this 154 will be divisible by k. Now check. 4 is divisible? No. But 2 is divisible. 7 is also divisible. How come? But if I divide this by 2, I'll have to change the options anyways. Chalo. Let's make it 5. Okay. So option C is the right answer. 154 should be divisible by k. See, basically what they are trying to tell us is, if I am dividing 158 by k, okay, I am getting something here, I am subtracting something here, and finally I am getting 4 as the remainder. That means 4 is excess. So if I remove this 4 from the quotient, from the dividend, then that value will be divisible by k. So that is what I am testing here. So options are going to be required in this case. If A is 22, B is 10, the value of k in the equation, this is what? So A is 22, just substitute. 22 mod 10 is equal to 22 plus 10 mod 22 minus 10 minus k. 22 mod 10 is 2. This is 32 mod 12 minus k. 2 is equal to 12 to 24, 24 and 8. So this is 8 minus k. So the value of k is 6. Simple, easy questions. Okay. Next. (7) equal to x mod 15. X is between 80 and 90. What is the value of x? 7 is equal to x mod 15 and x is between 80 and 90. What is the value of x? So if I have a number x, which when I am dividing by 15, I am getting the remainder as 7. Right? So what can be the probable value of x? Now that means this number, if I subtract 7 from it, should be divisible by 15. That is, x minus 7 should be divisible by 15. Okay. Or in other words, x minus 7 should be a multiple of 15, right? Now x has to be between 80 and 90. Okay. So what value from 80 and 90, if I subtract 7 from it, I will have a multiple of 15. So take the table of 15. 15 into 6 is 90. 15 into 4 is 60. 15 into 5 is 75. And 15 into 6 is 90. Technically, if I add 7 to all these three things, this is what they are trying to tell me. Okay. So if I add 7 here, this is 67. If I add 7 here, this is 82. And if I add 7 here, this is 97. So this is going to be my answer. Because x minus 7, this minus 7 should be divisible by 15. That should be a multiple of 15. So 82 is the correct answer. So you will go closest to the multiple of 15 where you will get a number by adding 7 to which you will get a number which is between 80 and 90. Okay. Last question for today. What is the value of this? So 4 into 5, that is 20% of 125 mod 12 square minus 11 square. Okay. 20% is 1 by 5. 1 by 5 into 125 is 25. 25 mod. Now 12 square minus 11 is 12 plus 11 into 12 minus 11. So 12 plus 11 is 23. 12 minus 11 is 1 only. 25 mod 23 is how much? 2. These are right answers. Okay. So the questions might seem difficult, but they are actually not very difficult. The basics are clear, then you will be easily able to glide through these questions. So what was the objective of the session today? The primary objective was to understand the complete concept and application of modulo division based arithmetic reasoning. So whatever questions they have asked you in the examinations are actually simpler than what we have discussed in the session today. Maybe the initial ones which were easy to solve. Okay. But we have learned some new concepts, some new tricks and some short tricks and some properties with which we can decide when to apply what, when to not apply that, so that we can make it fast or slow according to our requirement. And we practice some questions based on the principle today. So our outcomes are these and we have matched our agenda. Now I'll give you a homework question, which is this question. So please put the answers of this question in the chat box after we are done with the session. Alright. On that note, we'll end the session here, guys. Thank you so much for joining live. I'll see you guys in the next session. Till then, you guys take care. Bye-bye. Namaskar. Jai Hind.